So the stuff I showed you yesterday in perimeter, if we call perimeter man, what's he going to do? He's going to run around the outside of the figure, and he's going to add up all the sides. So if it's a rectangle, there's a few different ways you can do it. He could run around, he can add up all the outside lengths and do length plus width plus length plus width. I can do 2 times the length plus 2 times the width. There's a few different ways you can arrange it, but basically you're doing the same things. He's running around, he's adding up the outside. Why does he not go into the inside? Yep, this is a shock zone. No bueno. All right. And then I've got Area Man. And what's his superpower?
Inside. He can fly, he can duplicate.
He can fly. And what's his formula? Good. He flies around, he counts every square inch, and he's got a powerful formula that makes his life easier because area is length times width, and he's done. On problems that you're not sure if it's area or perimeter, perimeter is going to be distance usually around something. And then area is going to be covering like the surface area, the floor, the driveway, the yard, that kind of thing. So he does length times width, and you'll see A equals L times W most of the time. Volume Man's a little bit different, but he also has multiplication superpowers. Volume Man is my big guy. I call him my big guy because he not only does length times width, but he also does height. So when you get to a volume question, usually, not always, but usually, your volume questions are going to involve an answer that's on the larger side. So if you look at all your choices and A, B, C, and D are teeny tiny answers, you're probably not going to pull this superhero out because it's not going to be the right one. So Volume Man also multiplies, but these have to do with 3D shapes. Area and perimeter, both of these have to do with 2D shapes. What's the difference between a 2D shape and a 3D shape?
A 2D is like a picture.
Yeah, it's flat, like a picture. Uh-huh.
A 3D is like you can grab it.
You can grab it and hold it. Good. So for 3D shapes, he's going to do the volume, length times width times height. And as I showed you guys before, base times height. This is what you're going to be seeing next year when you go to 6th grade. The large B is what is represented as the area of the base. On a rectangular prism, the base could be the top or the bottom of the box or the figure. So if I'm looking for the area of the base, I can call this the base, or what it's sitting on the base. It's basically the top or the bottom. Does that make sense? So when we're looking for volume of a 3D figure, you're going to take all three numbers and multiply them together. If you try to start adding some of these guys together, you're going to end up with a really messed up problem, okay? Don't add the 4 and the 5 and multiply it times the 7. It's going to end up very badly. So if I wanted to find the area of the base, underneath here, what it's sitting on this bottom side, looks exactly like what is on this top side. If I go get a tissue box and I measure the bottom of the tissue box, it's the exact same as the top of the tissue box, which is why either one can be called the base. I flip it around, the base is now in a different spot. It still has the same dimensions. So what would the area of the base of this rectangular prism be? What would I multiply together? Meredith? It's actually 5 and 7 because it's this bottom part. The 4 and 5 is the front part here that's facing you. The base would be the 5 and the 7. So I'd multiply those together to get the area of the base. But I know I'm going to do length times width times height. So would you guys rather do 35 times 4 or 20 times 7? 20 times 7. There's no law that says you have to do it in a certain order. Rearrange those babies until it makes it to where you can do it in your head. Okay? So I know in order to get the volume of this, I'm going to be doing 4 times 5 times 7. 4 times 5 is 20, and 20 times 7 is 140. Now, if I add inches here, my answer is going to be in cubic units. So it's going to have a little baby 3 up there. When you see the exponent of 3, that means cubed. You're talking about a 3D shape. Sometimes it'll ask you how many cubic units you can fit inside something. It's just how many little blocks would be used. If it doesn't give you inches, then it's automatically by default cubic units. If I give you, for example, let's say that's a cube and I measured all the sides. It doesn't look very straight right now. Let's say I give you a cube and I say, this is a cube and each side is 4. Did I tell you inches, centimeters, feet, miles? Nope. So if there's nothing there, you just call it units, cubic units. That's kind of your default generic answer. Does that make sense? On the cubes, the most common thing I see kids do, what do you think it is? What do you think people multiply together?
4 times 3
Because they see 3 4s. Do not do 4 times 3. It'll give you a really messed up answer. You're going to have to do 4 times 4 times 4. 4 times 4 is 16. 16 times 4. Am I getting a big number?
Yeah.
So when you're doing the cubes, you're going to really, really, really want to do 4 times 3, but you can't. Because this guy here has to be calculated 4 times 4 times 4. 4 times 4 is 16. And 16 times 4, my mental math friends?
64.
64. And if it doesn't give me anything, I'm going to put units and my exponent of 3 to represent cubic units. Does that make sense?
He just didn't know if we eliminated